The Sahara Desert. Sahara is synonymous with the word desert, perhaps the largest desert ever. Merely mentioning the name of this world-famous region leads you to picture blue sky, windswept vistas, and a dune-filled desert. Your mind's eye does this without a second thought. The Sahara Desert is vastly more complex than sand, sun, and dunes. Little here is truly what it seems. What would happen if the surface got scratched, revealing more than expected? The Sahara encompasses incredible geological features, changed climates, ancient civilizations, and more. Like any significant ecosystem of the globe, the Sahara contains much more than we think. Words are used to tell people the Sahara is the world's largest desert. If words cannot convey the picture, a comparison does. The Sahara would cover most of the United States. The Sahara stretches from Mauritania and westwards to Egypt, covering most of North Africa and 11 countries. Roughly a third of the African continent is this desert. At its broadest, the Sahara is 1,100 miles or 1,800 kilometers wide. The Sahara is a little over 9 million square miles or 8% of the world's surface. The Sahara encompasses rolling deserts, mountains, wadis, oases, dry lake beds, and recently discovered fossils. Asia's Gobi Desert and America's Western deserts don't compare. We know the Sahara's a desert, but only 20% is sand. The sand consists of vast areas of dunes and more. A famous example is the Erg Chebe Dunes in Morocco. According to a 2019 United Nations study, the Saharan countries are home to 1.8 billion people. Combined, that's more than Europe and the United States. The Sahara also touches the Atlantic Ocean, the Mediterranean and Red Seas. The Sahara's estimated age is around 7 million years old. The Sahara started as a desert, formed from the remnants of the Tethys Sea, when the two ancient supercontinents crunched together, leaving a dust bowl. The rest became the Mediterranean Sea. Scientists believe the desert has remained unchanged for thousands of years, until recently, at least in geological terms. As we'll see, that changed gradually. During the late Pleistocene, or up to about 1.6 million years ago, the Sahara changed little. The climate gradually changed from 25,000 years to 20,000 years ago, becoming wetter. How and what was the result? At that crucial 250,000-year mark, the Nile River poured through a wadi, or ravine, and spread slowly across part of the Sahara, forming an almost inland sea covering more than 108,000 square kilometers at its peak. A second smaller lake formed simultaneously, though only 42,000 square kilometers. Fish bones and other evidence shows the lake reached almost 250 miles from the Nile. For comparison, the island country of Iceland is almost this size. Let's picture that on a map, and then slide that image over North Africa. This prehistoric lake disappeared over time, but others, like the Megachad Lake, appeared in more recent times. Introducing these changes will radically affect any environment. A savanna or grassland-type environment was created. Much of the area became more like what we see now. Diverse animal life from herbivores to big animals like elephants and rhinos. Like the Neolithic people and animals, more recent civilizations that came and went with the cycles depended on several newly formed rivers and some lakes. Human migration increased because of this much more favorable climate. We've gathered that the Sahara changed little until about 20,000 years ago, but another ice age happened, locking up much of the world's moisture. For another almost mind-boggling 10,000 years, the Sahara became cooler and drier. The lush grasslands shrunk as the Sahara grew. Any people living migrated to the fringes, such as the mountains or more southern grasslands. Any of the lakes or rivers that thrived also shrank. One example is Lake Chad took on roughly the dimensions we see today. But as we see, events in the Sahara are cyclical. Even the mighty Nile changed course, slowly moving to where we see it on maps today. Starting at the 10,000 year mark, the Sahara again took a turn. The Sahara went green, precipitation, and vegetation again increased, causing an increase in agriculture and human and animal populations. The Saharan changes can be easily found. Lake Chad grew to its maximum size. Other lakes formed as well. The best one known was Lake Darfur. Even great rivers appeared during this time. The most famous, the Tamanrasset River, flowed from the Atlas Mountains, and another spot flowing west towards the Atlantic Ocean. This green era went on for around another 5 millennia. For any person or even civilization, 5,000 years is unimaginable. But we quickly understood that this era is merely a blink in time. The Great Desiccation or Dryout began around 1,000 years ago and continues still. And like anything that no one really could understand, what caused this escalated change? The sources for the dryout are much more explainable and connected. One is climate change, which caused the second, reduced monsoon or wet season, and how the Earth's orbit tilted. A third is much less vegetation because of the more arid conditions, which may be linked to people. Vegetation means firewood for fires or building materials. People need to clear land for farming and livestock. So what's going on now? What we watched explained how the Sahara formed, what happened over a several million-year period, and what has remained. The Sahara we know now is the same as it appeared to the Romans and Egyptians. Whether from its prehistoric formation, when the mighty continents formed and crashed into each other, or when the Sahara's wobbly wet and dry cycle happened. The Sahara's vastness and harshness attract all kinds of adventurers. So what's under all that sea of sand left behind by the seas, lakes and dried-up rivers? So many mysteries have been or wait to be discovered, whether these are found easily or only those visible by satellite imagery. Let's talk about what resulted from the Sahara's rivers and lakes, with so incredibly massive ones repeatedly evaporating to eventually form again. Over centuries they created natural aquifers that have benefited mankind. Hidden beneath the deep Saharan sands are 4 great aquifers. These non-renewable water sources, also known as fossil water, may be the Sahara's most important resource. As we saw, the aquifers were created by the great water's ebb and flow. Much of them occurred in areas of absorbent sandstone and similar material. Until recently, none of the Sahara's inhabitants or societies knew about these hidden gems. The only presence was the all-important oases that dotted the deserts, fed by the aquifers. The water evaporated as the arid conditions worsened, and substantial amounts got trapped in these layers, creating huge underground reservoirs. The biggest of the 4 Saharan aquifers is the Nubian Sandstone Formation, or NBS. The aquifer is in parts of Egypt, Sudan, Libya and Chad. Discovered in the 1950s during exploratory drilling, no one knew how big the NBAS were. Not until the 1980s, using satellites, was the precise size known: 2.6 million squared kilometers. With careful management, governments in the area can carefully tap this water for fresh water and farming. The northwestern Sahara aquifer system is the second largest of the other 3, almost comparable to the NBAS. As any viewer knows, there are few regions of the Earth that man hasn't explored. The Sahara is certainly not one. Man's presence can be found from 200,000 years ago to the later Garametes civilization. Among the first recorded people in the Sahara were the Aterians. Like many hunter-gatherers, the Aterians moved continually following herds and available food. Their first presence dates back to Morocco and Algeria, beginning around 200,000 years during an arid time. The clues to their existence are red ochre dyes found in the caves they dwelt in. The dye was thought to be used for rituals. The Aterians also made stone tools using a tanged point. This is a stone that gets chipped into a shape, but a short stem remains attaching the device to a shaft. The Aterians demonstrated that early humans could adapt to such a harsh environment. Numerous cultures thrived in the desert far from the coasts. Being more advanced than pastoral dwellers, said cultures changed their surroundings. These farmers turned traders flourished around 1000 BCE. At their height, even the Greek Herodotus wrote about them. Despite the parched situation, the Garamantes farmed the dry silicate Saharan sand. They tapped the massive aquifers. They built many underground tunnels and canals called kanats to bring water to the surface. Next, they brilliantly invented water wheels called sakias to pump that water into the fields. Crops like wheat, barley and olives became staples. The Garamantes became skilled enough to become prosperous merchants, controlling trade routes from the coast into the rest of the Sahara. Like many secrets, the Saharan sand did not allow for too many facts about the Garamantes. Archaeological digs only exposed some of their success. Not until the 1960s, using aerial mapping revealed how extensive their agriculture reached. Later, high-resolution satellites or ground-based mapping allowed for deeper scans revealing trade routes, fields and towns. Their civilization became one of the few Saharan cultures not formed on a central river valley. They indeed were in the midst of the Sahara. The Sahara's sands truly do hide much, and only reluctantly give up any secrets. The geology of the desert included continents crashing together and volcanic activity. Such conditions make for a trove of natural riches found beneath the sands. The most useful resource is conceivably oil. Oil is formed because of pressure and organic material like plants, which heat up with other processes over time to create oil. Like fossil water, the oil gets trapped in soft rock layers like sandstone. This gooey liquid powers the world. Egypt and Libya are the biggest extractors of oil and natural gas from the Sahara. Oil is an essential part of these countries' economies. As we'll discover, much more than oil lies buried beneath the sand. Many of these materials are found in certain areas and not across the entire Sahara. An important resource for fertilizer such as phosphate is primarily found in Morocco. Much of this is exported to Western countries. A second important one is natural gas in the same countries as oil. Uranium, used in nuclear power plants, is mined and may be the most extensive available source. Lead and zinc, used for many industrial processes, are found in several areas. Uncommon minerals like gold and gems are mined in several countries. Small mining operations usually unearth Nigeria's gold. Gems like amethyst, agates, and quartz are found in several spots. Even the Sahara's sand and stone can be used as valuable materials. Look at silica sand, the primary sand for the desert, used for making glass and steel foundries. Stone types common to the Sahara include sandstone, granite, and marble, all solid materials used for construction. The Sahara sands eventually revealed the most unusual substance found along the Egyptian border with Libya: Libyan glass, or tektite. Some 26 million years ago, a meteor crashed into the desert, melting the sand at 1600 degrees, becoming glass and taking on a yellow-gold color. Local peoples used Libyan glass for centuries, but only became known to the West in the 1930s. The only known deposits are found in Egypt. Finally, we come to what intrigues and fascinates us the most: the fossils. The ancient bones give us a glimpse into what existed. The Sahara we know was part of the Tethys Sea millions of years in the past, which submerged great swathes. Vegetation and rainfall came and went with the climate cycles, creating and drying out megalakes or rivers. Much of the exploration started in the early 1920s. Dinosaur fossils found nowhere else emerged from the Sahara. One of the more unusual ones is the Spinosaurus from the Cretaceous period, about 110 million years ago. Typically, this dinosaur lived along rivers and coastal areas, feeding on fish and other animals. The Spinosaurus also lived across the Sahara, with bones found in Egypt and now Morocco. The Spinosaurus was a carnivore with a huge sailfin on its back. The sailfin had long spines, and scientists are sure of the sailfin's purpose. Theories include regulation of body heat displays for mating or threat or swimming. The Sahara was covered by great lakes and shallow seas, starting back 250 million years ago. Typical spots to find different fossils are in Libya and Egypt. Marine creatures such as ammonites are common. Ammonites are an extinct curved-shelled creatures similar to today's nautilus. Mammals have been found as well, though not as old. The farthest back remains come from the Cenozoic era, at 66 million years. Less than 70 almost doesn't qualify as fossils. The oldest and repeatedly found fossils are from plants. These fossils go back in time the farthest to the Paleozoic, a whopping 500+ million years ago. Located across the Sahara, they represent a time when the Sahara was humid and vegetated. What's hidden under the Sahara is both fantastic and varied. Ancient civilizations, fossils, and minerals are just a few. The desert sands are averse to revealing what's located within them. Many secrets simply could not be found by digging. Our knowledge of the Sahara has only expanded because of technologies like ground mapping, satellites, and deep scanning radar. The Sahara constantly fluctuates. Since 1920, the desert has expanded by 10%. Whether by the Sahara's natural cycle or global warming has not been determined. Even with all that mankind has discovered in the Sahara, we still have much to learn. Thank you for watching, and if you enjoyed our video, please give it a like and subscribe.